So let's do a quick example comparing the slope versus the curvature of a function at a point. First, let me give you guys a picture for y is equal to x squared, which is our good old friend, our good old parabola. Let's say here is 1 and here is 1. So if we want to find the slope at this point, what we are really saying is the slope of the tangent line, right? So right here, let me draw a tangent line like this. So you can see that the line goes upwards, so it's positive, all that stuff. And all we have to do is, this is our function, just take the derivative. Y is equal to x squared. Do the first derivative, we get 2x. And then we care about when x is equal to 1. So the slope is just equal to 2. Right? And that is equal to m as our usual notation. The slope of this tangent line is 2. Done. Now, how are we going to find the curvature right here at this point? The answer is we have to use the formula that I showed you guys in one of my previous videos. Here we go. Kappa, and this depends on the x value that we use, right? This is equal to, we have the second derivative of the function, so let me just write it like this. Y double prime over 1 plus y prime, and then square that, and then raise that to the 3/2 power. And the truth is, make sure you put absolute value on the top if you want non-negative curvature. So here we go. We know y is equal to x squared. The first derivative is 2x, and then the second derivative is just 2. So for our kappa, this right here is equal to our second derivative over 1 plus our first derivative squared, and then raised to the 3/2 power. So we can simplify this a little bit. Absolute value of 2 is just 2, and work that out, we get 4x squared, and then raise that to the 3/2 power. And we want x to be 1, so our curvature kappa at 1 is just 2 over 1 plus 4 times 1 squared, and then raised to the 3/2 power. And if you work this out a little bit, this is just going to be 2 over 5 raised to the 3 over 2 power. The over 2 power, it's the same as the square root. So we can write this as 2 over the square root. And we can work out 5 to the third power, which is 125. So this is a curvature at that point, which you can tell that this is actually a quite small number, right? So the difference is, this right here is a slope. It measures how much you go up and then how many times you go right? So we go up twice and then we have to go to the right once. But the curvature is, just think about it as how much we're turning right here. And we will have to consider our unit tangent factor at this point. And then if you continue the same fashion, you can see that it's not really turning anymore, because it's like in this direction. It's not really turning anymore. In fact, if you look at the origin, the slope of the tangent line is 0, but what's the kappa here? Let me write it down. The kappa here is equal to 2 over square root of 125. But how about the kappa at the origin? Let's work out that real quick. Kappa of 0, it's not 0 because the top is 2. Over, put 0 in here. So it's 1 plus 4 times 0, and then squared, raised to the 3/2 power. The inside is just 1, so 2 over 1. So in fact, the kappa at 0 is 2. So the kappa right here is 2. Because we are coming down, let's say in the usual orientation, right here, we have to turn this much. It's like that. It's like you have to turn like this. Oh, let me just draw it again like this. It's how much this is bending with respect to the arc length. Yeah? Here's a question for you guys. is this the place that we have the biggest curvature for y is equal to x squared? Leave a comment down below and let me know. Then that's it.